Welcome friends, welcome to the third set of questions in machine learning, and I am telling you try to solve this set of questions online as I am telling you because they are very simple. So this time you can definitely give a try. Just be logical. So first question is, when performing regression or classification, which of the following is the correct way to pre-process the data? How are we going to pre-process the data? Normalize the data, then do PCA, principal components, this thing, and training. Then PCA, normalize PCA output, training, normalize the data, PCA, normalize PCA output, and so when are we going to do the principal components analysis? That's the question. So anything you are doing, you will normalize it first. So normalize the data, then do PCA, principal components analysis, and then do training. First doing PCA is no meaning before normalizing, and after PCA again normalizing doesn't mean anything. So the answer is A, normalize the data, then do PCA, principal components analysis, and then do training. You need to always normalize the data first. If not, PCA or other techniques that are used to reduce dimensions will give different results. Results will be wrong. Now second question is, which of the following statements about regularization is not correct? Regularization. Using too large a value of regularization coefficient lambda can cause your hypothesis to underfit the data. Yes, if you will use too large a value of regularization, then what will happen? It will make our model very simple, because what does regularization does? It punishes the complex models. It boosts the simple models. So once our models get simple, then our data will get underfit. So too large a value of regularization will underfit the data. That's the correct answer. Using too large a value of lambda can cause your hypothesis to overfit the data. No, that's not the question. No overfit. Using a very large value of lambda cannot hurt the performance of hypothesis. No, it will hurt. It will underfit. It will punish complex models. That's how the underfitting starts after regularization. So using too large a value of regularization coefficient lambda can cause your hypothesis to underfit the data. A large value results in large regularization penalty and therefore strong preference for simpler models. What we do in the regularization? In regularization, we actually punish the complex models, because those complex models, we assume that they have emerged from the noisy data, they have emerged from the outliers, so they need to be regularized, they need to be punished. Otherwise, data will not generalize. The model will not generalize. It will fail in the actual situations across different data sets. Variance error will be too high. That's the thing. In which of the following cases will k-means clustering fail to give good results? When the k-means clustering will fail, as we saw in the lecture 1, that k-means clustering, where it was defining that how many clusters will be there, and that those many spheres it was making. So data points with outliers, where it will fail. Yes, in data points with outliers it is going to fail. Data points with different densities, again it's going to fail, because it simply takes the distance. And data points with non-convex shapes, again it will fail. Non-convex shapes, different shapes. So all of the above will be the answer. K-means clustering algorithm fails to give good results when the data contains outliers, data is lying outside, the density spread of data points across the data space is different, and the data points follow non-convex shapes. This is again the K-means clustering fails. Which of the following is a reasonable way to select the number of principal components K? principal components analysis. In that one we are trying to choose principal components K, choose K to be the smallest value so that at least 99% of the variance is retained. Yes, that's very much required. We have to choose K less. Choose K to be 99% of K rounded to the nearest integer. Choose K to be the largest one so that 99% of the variance is retained. No, 99% of choose K to the smallest value. K has to be chosen smallest value so that at least 99% of the, because K is that how much data will be left. So this will maintain the structure of the data. We need to keep this K less. What is the purpose of regularization in machine learning? Very simple question. To reduce the number of features in a model, or to prevent overfitting and improve generalization, or to speed up the training process, or to increase the accuracy of the model. Of course, B, to prevent overfitting and improve generalization. Regularization is done to prevent overfitting, to punish complex models and help simple models to be implemented. So, to prevent overfitting and improve generalization. Regularization is a technique used in machine learning to prevent overfitting of the model to the training data and improve its generalization performance. It doesn't reduce the number of features in a model, speed up the training process or directly increase. It simply punishes the complex models and helps the simple models to evolve so that data can be generalized. It is seen that complex models don't generalize. They exactly fit in the training data set, keep bias error low, but variance goes very high. What's the difference between a validation set and a test set? A validation set is used to tune the hyperparameters of a model, while a test set is used to evaluate its performance. Very true. A validation set is used to evaluate the performance of a model during training, while a test set is used to evaluate its performance after training. A validation set and a test set are the same thing. A validation set is not necessary in machine learning. Of course, first is correct. A validation set is used to tune the hyperparameters are tuned through validation set. After training, you do validation. So through a different data set from training, you tune the hyperparameters, then you give it to the test set. So A is the right answer. A validation set is used to evaluate the performance of a model during training and tune its hyperparameters, while a test set is used to evaluate its performance after training and hyperparameter tuning. After hyperparameter tuning it's used, and validation set and a test set are not the same thing. A validation set is usually necessary in machine learning to prevent overfitting. What happens when we apply our model on training data set? Then we try to reduce error, bias error is reduced, but variance error increases, overfitting happens. That's why we need validation. Which of the following is an example of a classification problem? This is more of a common sense thing. We have to think, a quiz type of thing. Predicting the price of a house based on its features. Is it a classification problem? Predicting the classification means there will be some number, some class as its output. Price will be a common thing, means it will be a continuous thing. There will be no category as such. Predict the price of a house based on, unless it predicts that whether this house is for rich people or common people or poor people, then it may become classification. Otherwise, it's a regression problem. Predict the weight of a person based on their height. Weight can be any, it's a continuous variable, so it can't be a class. Again, if it defined that whether he's fat or average or athletic like that, then only it will be a class. Predict whether a customer will churn or not. Yes, this is a class. Whether he will come or not, so yes or no type of classification is there. Predict the age of a person based on their income. Age, again, it's a continuous. So this will churn or not, this is the answer, because it's in yes or no. Classification is a type of machine learning problem where the goal is to predict the class of an input. Now, which of the following is an example of a clustering algorithm? Whether it's decision tree or random forest or k-means or gradient descent, we all know k-means clustering is very common. Decision tree is not clustering, random forest is not clustering, and gradient descent. K-means. Which of the following? K-means clustering is a popular clustering method used in machine learning. Decision tree and random forest are tree-based models, while gradient descent is an optimization algorithm used to many machine learning algorithms to minimize the loss function. So those are not clustering. What is the purpose of feature scaling in machine learning? What is feature scaling? To convert categorical features into numerical features, or is it to reduce the dimensionality of the feature space, or to standardize the range of numerical features, to introduce new features into the model? So feature scaling is about to standardize the range of numerical features. That's what we do, to standardize the range of numerical features. Feature scaling is a technique used to standardize the range of numerical features in a data set. This is important because some machine learning algorithms are sensitive to the scale of the features, and feature scaling can help improve the performance and convergence of these algorithms. Now the last question, what's the purpose of cross validation in machine learning? Why do we do cross validation? Again, to remove the variance error, to stop overfitting, to evaluate the performance model held out test, to evaluate the performance model on different subsets on the data, to compare the performance of different models, or to tune the hyperparameters of a model. Basically, we tune the hyperparameters of a model, but here the answer is to evaluate the performance of model on different subsets of the data. When we do work on the different subsets of the data, cross validation is a technique used in machine learning to evaluate the performance. So actually, validation is done to tune the hyperparameters of model, but what this problem is talking about is cross validation. So that is not to that is to test the different subsets of the data. You want to evaluate the performance. That's why cross validation is done. Cross validation is a technique used in machine learning to evaluate the performance of a model on different subsets of the data in order to assess its generalization performance and detect overfitting. So cross validation is, that's why it is so much important. It doesn't involve a held out test set or hyperparameter tuning, but can be used to compare the performance of different models. So that's why cross validation is different. Thank you.